So this is Brainy Daps. Wherever it is you are watching this video from, be it Twitter, Cargo, GitHub, or Upwork, or wherever it is you got this from, this is a quick demonstration of the AI infused application called TalkingStage. It's meant to go through the talking stage for romantic interest, people who are interested in dating each other and do not want to go through the stressful and dreaded talking stage. So this talking stage app makes use of machine learning principles working behind it to help users to answer questions rather than them being the one answering the question. So let's start and see how this works. Now you can see this is just a pop out to let the user understand how questions are meant to be imputed, to be separated by comma when there are multiple questions that are to be asked. Now let's ask it some series of questions that are typical during the talking stage. So these are the very common questions that people can ask during the talking stage. Can go on and on and on and on like that. So this is just an example of a question that someone might ask. And so on and so forth. So we're going to click on send and see the answer that it brings to us. So now you can see the answer here. So it brought your name, your age, your location, your hobbies, your passion, best color, best food, your horoscope sign. Now you can see that although some of the questions were not answered, like animals was not predicted, was not answered, passion was answered, hobbies was answered, location, age, name, and all other things that were asked were answered, except for the animal, which wasn't answered for some reasons. So what this happens is that what you're seeing on the screen now are just placeholders. Your name, your age, your location, your hobbies that the chatbot gave us are just placeholders. So the placeholders are going to be edited in the code behind to your own specific information. So in place of your name, you put your real name, your age, you put your real age, your location, you put your real location in the code behind, so that it will be able to bring out the actual one. So you might be wondering, how did I make all this? How did I make this possible? Now this is how I made this possible. I randomly selected an algorithm that will be used for making prediction based on the user inputs. So once the user inputs a question like, say, what is your name, and I click on this, it tells me what my name is, your name. Now this has been trained in the code behind. There is a training data in the code behind that is a collection of all the common questions that they usually ask and different ways those questions can be asked. You can see the training data that is behind it. Everything has been mapped to name. Title mapped to name, appellation, designation, moniker, denomination, handle, identity. This has been mapped to name. Not only single words alone, but also full sentences like what is your name has been mapped to name. Tell me your name has been mapped to name. What are you called? What to call you? Who are you? Who be you? Can I know your name? May I know your name? What people call you? And so on. Different variations in which people can ask this question is in the training data. So the machine learning now tries to see patterns in the relationship between the input and what the user is actually asking for. Now you would notice that its name that is in the label column, name, but in the application it's actually showing what is actually showing your name, and this is because of the way the program has been structured. If you go to the training bot CS, which is one of the code behind, you would see that name is the key in the dictionary of response in the code behind that has the value your name. So your name that you are seeing here is what the chatbot will actually give to you instead of name that is actually predicting. The reason I did this is so as to remove personal information from the training data. So instead of the machine learning from the actual information in the training data, it's only going to be learning the key of the dictionary that is behind, that is in the code behind. So you don't need to be worried about your personal data being processed by machine learning or whatnot. And you would notice that some of the things that I was trying to predict was not actually predicted, like animal, your best animal, for instance, is actually predicting it wrongly as your location. This is because the algorithm that is responsible for it in the training model code behind it, this algorithm is called the SdcaMaximumEntropy. It uses a coordinate descent method for predicting what the user is actually trying to ask. But when I ran the automatic machine learning toolkit in the ml.net library, it suggested that there is a better model for making a better prediction than what I'm already using. And that model is called the Light GBM. It uses a gradient boosting decision tree method for making prediction, which is a much more superior algorithm than what I am already using in my application called the SdcaMaximumEntropy, that just uses a coordinate descent method. So in the next release of my application, I'm going to change this algorithm to a better algorithm that has been suggested to me by the Auto Machine Learning Toolkit of ML.net. So I hope you enjoyed this brief explanation of my AI-infused talking bots. So whatever question you might have, all you need to do is just to send this application to your love interest, and it's going to answer any question that you would have. It does not even have to be written in a particular way to be able to predict. You see now, Where Do You Live is predicted as your best movie. It's not really accurate. The algorithm I'm currently using is not accurate, but subsequently it's going to be predicting it accurately in future when I use that algorithm that has been suggested by the automatic machine learning toolkit. So I'll see you again next time for another demonstration, or possibly to show if there's any improvement in this talk in this chatbot.